Okay, so let's continue with section 8.8. Last time we left at number 2. Now we continue number 3. So first step, we're going to FOIL because this is 2 binomial, right? So let's FOIL this. 2 times 3 is 6. 2 times negative 2i is negative 4i. 3i times 3 is positive 9i. And then 3i times negative 6i is negative 6i squared. And again, negative I squared is negative 1, so negative 6i squared become positive 6, right? So this term right here become positive 6. 6 plus 6 is 12. And then combine like term, negative 4i and positive 9i, that's 5i, so plus 5i. And that will be your final answer. Okay. You may want to pause the video a little bit and try this one on your own. Now this one, we can do either foiling or because they are conjugate, right? Because we have 7 plus 11i and 7 minus 11i, we can use difference of 2 squared, right? Because we have a squared minus b squared. Let's recall a squared minus b squared equal a plus b times a minus b. Now we're going to reverse engineer, right? We have a plus b times a minus b. We can rewrite it as a squared minus b squared. Here, a is 7, right? So 7 squared minus b is 11i, so 11i squared. Make sure you put the parenthesis around 11i because you square both 11 and I, not just I, right? 7 squared is 49. 11i squared, 11 squared is 121. I squared is I squared. We know I squared is negative 1. So this becomes positive 121. And then combine like term, right? 49 plus 121 is 170. Well, plus 0i, right? Because they want to inform a plus bi. All right. Okay, number 5. Now, I hope nobody doing this. It's a very common thing for 661 and 62 student. They love to distribute that square into the numbers. Now, you only allowed to do that if what? If 3 is times 2i's, right? Between them are multiplication or division. But if there's plus or minus, we cannot do that. Well, what we can do is we can write it out twice and then we can FOIL it. So 3 plus 2i times 3 minus 2i. So let me turn on my videos. You can see me. There you go. All right, now we FOIL. 3 times 3 is 9. 3 times negative 2i is negative 6i. 2i times 3 is positive 6i. And then 2i times negative 2i is negative 4i squared. Well, negative 4i squared become positive 4. Right? We all agree that when you see a I squared, you convert that number into positive and you drop the I squared. Right? So this becomes plus 4. 9 plus 4 is 13. Oh, you know what? It's 3 plus. I'm so sorry. 3 plus 2i times 3 plus 2i. So this guy's supposed to be plus. 6i plus 6i is 12i. So we have 13 minus 12i. Plus 12i. Okay. Now there's another way of doing this. Maybe I'll show it to you. So the FOIL always work, right? Another way of doing this, I don't know if you guys recall. This table is making noise. Hang on. Let me move myself to the left a little bit. Okay, another way. Recall. If you can remember, a plus b squared is equal to a squared plus 2 times ab plus b squared. I'm showing you this just because the books have this things show, but you feel free to just FOIL it. Okay, most people, students just use that method. But for me, if I do like long math problem, I prefer this method, the blue one. So I have 3 plus 2i, all of that square. A is 3, right? A is 3. So what does that mean? And we have 3 plus 2i squared. So now we have a is 3 and b is 2i. So a squared will be 3 squared plus 2, not 2 right there, 2 times a. What is a? A is 3 and b is 2i. I put in parentheses to distinguish between a and b. Plus b squared. B is 2i, so 2i parentheses square. So I got 9 plus, what is that? 12, right? 12i plus 4i squared. You know what? I think I make a mistake right here. I'm so sorry. It's, remember that minus thing? So everything is gonna be plus. So this right here is minus 4, not positive 4. So minus 4. 9 minus 4 is 5. All right, I think we're good. All right, so 4i squared here become negative 4, right? I squared is negative 1. 4 times negative 1 is negative 4. 9 minus 4 is 5 plus 12i. Whichever way from your boat. For me, I like the blue one. It just faster, and I always remember the formula. But if you don't want to remember anything, FOIL always work. Comic of the day. Yeah. All right, conjugate pair. Do you remember conjugate pair? Right. Let me recall something. If I give you x plus y, then conjugate of x plus y will be x minus y. Right? X minus y. Now, for dividing complex number, if you remember for the previous section, we rationalize the denominator, right? That means we don't want radical, we don't want root in the denominator. Same thing here with the complex number. We don't want I in the denominator. We want to get rid of it. And one way we can do that is to times the top and bottom by the conjugate of the denominator. So the first step will you multiply the numerator and the denominator by the complex conjugate of the denominator. And then the second step is simplify. So the conjugate of the denominator for number 1 will be 3 minus 4i. Okay, so times 3 minus 4i over, maybe I'm going to use 3 minus 4i over 3 minus 4i. Basically, we times it by 1. And now you FOIL. Because let me do the bottom first because it's easy. Now the bottom is because they conjugate, they only change the size in the middle. So it's kind of like a plus b times a minus b, right? So it's going to be a squared minus b squared. A is 3, so 3 squared minus 4i, b is 4i, so 4i parentheses square. Well, 3 squared is 9. 4i squared is 16i squared. 16i, negative 16i squared becomes positive 16i squared. Okay, we agree this turned positive. 9 plus 16 is 25. Move it to the middle a little bit. Okay, so that's the bottom. Now the top, we FOIL. The two binomials are different, completely different. So the only way we can do this is we FOIL them. 5 times 3 is 15. 5 times negative 4i is negative 20i. Negative I times 3 is negative 3i. And negative I times negative 4i is positive 4i squared. And we know that positive 4i squared turn negative 4. 15 minus 4 is 11. 20i minus 3i is minus 23i. So 11 minus 23i. Now, don't stop. We want it in standard form. Remember, standard form is a plus bi. This does not look like a plus bi. Right? We need a and b to be separate. There's no common denominator in between a and b. So what I'm going to do, I'm going to split that number. So it's going to be equal to, he's going to rewrite it equal to 11 over 25 minus 23 over 25. So now we have in the form a plus bi. Okay. That's it. That's your final answer. Okay, I would suggest you try this on your own. This one right here, negative 3 over 5 plus 2i's. So again, divide complex numbers is kind of similar to rationalize the denominator, meaning you don't want I in the denominator. So we're going to multiply both top and bottom by its conjugate of the denominator, which is 5 minus 2i over 5 minus 2i. Let's take care of the bottom. It's going to be 5 squared minus 2i, all of that square. 5 squared, 25. Minus 4i squared. Well, 4i squared is, negative 4i squared is positive 4. 25 plus 4 is 29. Now, the top, we distribute. Negative 3 times 15 is negative 15. Negative 3 times negative 2i is positive 6i. Let's rewrite this here. All right. Again, don't stop. You're going to rewrite in standard form. So split it apart. Negative 15 over 29 plus 6 over 29 times I. You can put I on the top next to the 6 if you want, or you can put it kind of right next to the division symbol, right? That line. Just do not put I in the bottom, okay? It's totally different things. All right. Now the power of I. Okay, before we talk about the power of I, let's write out a first few power of I. Right. So first, I to the 0. You guess it, 1. Right. Well, I to the first is I. It's nothing. What about I squared? Negative 1. Right. Now, I to the first, you can rewrite it as I, or some people write it as square root of negative 1. It's not wrong, but I'm gonna keep it at I, okay, because I don't want square root in my answer. IQ is I squared times I. Well, I squared is negative 1 times I, which is negative I. I to the 4 is I squared times I squared, which is what? Negative 1 times negative 1, which is positive 1. Let's get a few more. This time I'm going to do blue 1, right? I to the 5th is I to the 4 times I. Well, I to the 4 is 1 times I is I. I to the 6 is I squared times I to the 4. Well, I squared is negative 1. I to the 4 is 1. Negative 1 times 1 is negative 1. I to the 7 is I, you guessed it, I to the 7 is what? I to the 6 times I, which is, well, I to the 6 is negative 1, right? So negative 1 times I is negative I. So do you see the pattern? Do you see the pattern? You start out with what? 1, and then you have I, and then negative 1, and then negative I, and then you go back to what? You go back to 1 and I, negative 1 and negative I again, right? So every fourth power is go back to the cycle, right? So no matter how big is your power of I, your answer will be one of the 4. Your answer either plus minus 1. I don't care how big is the power of I. Your answer is going to be either plus 1 or negative 1 or plus I or negative I. One of the 4. Right? Let me give you an example. I want you to evaluate or simplify I to the 201 power. This one I can rewrite as what? I'm going to rewrite this power. I'm going to rewrite 201 in something that one of them be able to divide by 2, right? So I'm going to split it into 2I to the 200 plus 1. Is that okay? This is equal to what? I to the 200 times I to the first. Yes? Remember the rule, if I have A to the m plus n is equal to A to the m times A to the n, or vice versa. Well, I to the 200 is I to the something, I squared, times something outside. What is that? What number times 2 gives you 200? Well, 100, right? And then we write I to the first. What I squared equal? Negative 1. I squared equal negative 1. So negative 1 to the 100. Maybe I'll do like this. Well, this right here is negative 1 to the 100. Well, negative 1 to the even power is going to be positive 1, right? The negative 1 squared is going to be positive 1, negative 1 to the 4. It's going to become positive 1. And then bring down the I to the first. So 1 times I to the first is I. So your answer is I. Same thing with number 2. You do exactly same procedure. So again, you're going to split the I of 1003 into a number that you can divide by 2, and the smaller one you cannot. Right? So what I'm going to do I to the what? 1002 times I to the first. Right? I skipped a step like 1002 plus 1. Well, 102, what is 102? Is I can rewrite it as I squared and then something outside. When I multiply the 2, give me back 1002. So if you take 1002 divided by 2, you got what? 10 divided by 2 is 5. 0. 501. Now you can check with your calculator. 501 times 2 gives you back 1002. Well, I squared is negative 1 raised to a odd number of power 5 over 1 is odd. If -1 raised to odd power will give you -1, right? -1 cube, -1 to the 5th, etc. So -1. And then bring down the I to the first. So equal to what? -I. That's your final answer. Why don't you guys try this? Maybe give you one more, number 3. I to the 2000. 2023. Now it's pause the video and just try that on your. Okay. So this one again we write it as I to the what 2022 times I to the first, right? Rewrite I 2022. This one. So this is I square. Inside we I square, and then some number when you multiply 2 give you back 2022. So you take 2022 divided by 2, you get 10, 11. I squared is -1 to the 10, 11. That's the odd number. So it's going to be -1. And then bring down the I to the first. So your answer will be -I again. Okay, so and any problem involving power of I will have that procedure. All right. There's a different way of doing this too, but I think this is the easiest way for you to understand. All right, that's it for 8.8, I believe. Thank you for being patient with me, and stay tuned for 9.1 next. Thank you.